In this second video for your census point 1, I want to go through the electromagnetic spectrum. So that's this section over here. So if we list through the things we've got to be able to do, the first thing is you need to be able to list the 7 ways of the electromagnetic spectrum in order. Okay, and as part of doing that, so 7 ways, let's have a look, in order, you need to be able to add the following labels. It's about wavelength and frequency and energy. Okay, it does say in order of increasing wavelength. So you want to go from the short wavelength to the long wavelength. So let's have a look to see whether we can find that. Okay, so if you scroll through this work, okay, you can see that we've got a nice diagram of the electromagnetic spectrum here. Okay, so if we look at wavelength, if that's the long wavelength side and that's the short wavelength side, okay, you're going from a short wavelength at this end to a long wavelength at that end. So the order I want is this way around. So gamma, X-ray, ultraviolet, visible light, infrared, microwave, radio waves. Okay, but to remember any order, just use this mnemonic here. Remember my instructions visible under X-ray glasses. So remember in the exam, they could get you to order them either way around. This end has a long wavelength, low frequency and low energy, so that's a bit of alliteration there to help you out. Yeah, this side has no alliteration, but that's a short wavelength, high frequency and high energy. Okay, let's get back to up over here. A bit more. There we go. Right, so next one is list the uses of the waves from the electromagnetic spectrum. So that's a D/C. Okay, but I'm going to move on to the B stuff as well, which is also so that's just uses. But to get the B grade stuff, we really need to talk about the harmful effects. Okay, so we're going to do D, C, and B all together. Okay, so if I scroll down slightly more. Okay, so we've got electromagnetic spectrum. Remember, they all travel at the same speed, the speed of light. That's 3 times 10 to the 8. And they travel moving energy from one place to another, so it's continuous, remember, as well, before I move on. Right, okay, so here is my table. It's got the main uses and the dangers. So guess what? You've just got to memorize this whole thing here. Okay, you've got to know them all. So let's go through a few of these. Gamma rays, they're used for sterilizing food. Okay, so it means that we kill the bacteria off food, and medical equipment, again, killing bacteria off there. You can detect cancer with it, but you can also treat it with it. Okay, and another thing, the dangers of it is it can actually cause cancer. So cancer is highly involved with gamma rays because it can kill living cells and cause mutations. X-rays, well, the main uses are for examining broken bones, looking at internal structure, airport security, those sort of ideas. Okay, and yet again, it can damage cells and cause mutations. Okay. Ultraviolet, okay, so security markings like smart water, they show up under, smart water shows up under ultraviolet. Some fluorescent lamps, okay, detecting forged banknotes, and also you can disinfect water, so kill the bacteria in some water using ultraviolet. If you get too much ultraviolet to surface cells or cells in your eye, it can cause damage to them, again causing mutations. Okay, that can lead to skin cancer. So we get a lot of ultraviolet out of the sun. That's why some people that tan too much end up with skin cancer, and also eye conditions. That's why if you ever go in a sun tanning bed, you have to wear the little goggles over your eyes. Visible light obviously enables us to see, enables us to take photographs and lights objects up. In other words, illumination. But if the light's too bright, it can cause damage to your eyes. Infrared, never ever say mobile phones use infrared. Generally, as a general rule, they don't. Okay, so what infrared is used for is cooking. Okay, because infrared is a transfer of heat energy. Remember, thermal imaging cameras, short range communications, say TV, television remotes. Okay, optical fibers. So you know when you're sending information down optical fibers, we can use infrared to do that, and some security systems use infrared as well. The main danger is that of skin burns. Okay, because this is to do with cooking. You can actually burn your skin using infrared. So when you put your hand under a hot grill and you felt that burn, that's the infrared radiation. Microwaves, well, they can be used for communication, mainly mobile phones. The reason why is because they can penetrate the Earth's atmosphere, the ionosphere of the Earth, from the upper layers. Okay, it can actually go through that. Radio waves cannot. Microwaves can go through the ionosphere. That's why you use them for communicating with satellites and for mobile phones. Also, we can use them for cooking because they heat up water cells. That's the danger. Okay, they can heat up body cells. Body cells are full of water, so they can heat them up if we're not careful. So the way it works with microwaves is it makes those particles, those water molecules, vibrate. Okay, microwaves make water molecules vibrate. That's how it can be used in cooking. But we can also have it to body cells if we're not careful. Radio waves, well, the main uses for those are in broadcasting. Okay, the radio signals, of course, communications, like walkie-talkies, those sort of ideas, and some satellite transmissions as well. So the last little bit that we need to know on this area is about Herschel and Ritter. Okay, so explain how the experiments performed by Herschel and Ritter led to discovery of the electromagnetic spectrum. It does say include a description of the experiment. Okay, you do need to understand what the experiment actually looks like. I'll do that quite quickly because I've got it very well laid out here. Okay, the idea is all they did was they split light using a prism. So Herschel discovered infrared rays. What he actually did is he did an experiment. He essentially just plotted a graph, and the graph was on this side it was color. So it was violet, let's say orange over there, and red over here, and this side was temperature. As he let's get my red back up there now. And as he plotted the graph, he realized that the closer and closer he went to red, the more and more it keeps going off just because it's too close. That's better. Okay, the closer and closer he got to red, the faster and faster temperature increased. When it went beyond red, it increased even faster. So you realize there must be some sort of wave beyond red, and he called it infrared. So the idea here is that he moved a thermometer across this spectrum, starting over here and moving across this way, and as he went beyond red, he went this way, and as he went beyond red, the temperature continued to increase faster. Okay, got it over here. He wondered what would happen if he moved beyond red. Okay, it continued to increase faster, therefore he found the invisible infrared waves, and that's the key thing for that one. So here's the experiment. So a prism splits the light, thermometers, and you just take the thermometer at different temperatures. You move the thermometer across, moved it into the infrared, and it was hotter. Ritter did the same work, looking mainly at ultraviolet though. So he moved across this way. He realized that silver chloride turned black when exposed to light. Okay, so when he moved it beyond violet and into the invisible rays over here, beyond violet, he realized that it turned black quicker when exposed to other colors. So when it exposed to violet light, it turned black quicker. Ritter showed it turned black even quicker when it was exposed to light beyond the violet end of the spectrum. So that's where he actually discovered ultraviolet, beyond this part of it. So it turned black quicker when he got closer to violet, then when he went beyond violet, that silver chloride turned black very quickly. So that's how we discovered ultraviolet. Cool, and that's everything you need to know about the second topic for your census point. So that's all the bits on the electromagnetic spectrum. You don't need to know the section on radioactive substances for your census point, although it can be on your actual tests at the end of year 11.